Testing. 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 Right. Up here. Cool, cool, cool. It's a little chilly today, so covering my head with some stuff. We got some espresso coffee. Switching over from the yerba mate yesterday. And happy Friday. Today we're going to be looking at continuing our Kaggle on ChatGPT. This might be the last stream of the series, maybe, depending on what happens. But to catch you guys up, we went ahead and ran our embedder yesterday. So we have 3 different files here. Basically, we took the entire train data set and then used a pre-trained language model to embed it, right, and basically create the training data set, such as this one right here, but then rather than the protein sequence as a string, which represents where each character in that string represents a amino acid or a residue, we converted it using this large language model that was pre-trained by Facebook. It's called ESM, and there's a couple different versions of that, ESM1V and ESM1V with a different data set, and then ESM2. We use those big pre-trained language models to basically encode our protein sequences into a latent vector. And then we're going to use those latent vectors to train a small little model head. And yeah, that's where we're at. So basically, since yesterday, we ran the embedder. So now we have basically our train and our tests ready to go. And I also went ahead and ran this optimizer, which basically just takes our training code and then runs it with a couple different hyperparameters here. So haven't looked at this, so we're going to go ahead and we're going to look at the actual Tensorboard. So this is the Tensorboard of what we ran. And when we toggle all runs, so a couple things here, right? On here you have your training loss, and then here you have your validation loss. So one thing I kind of always do with Tensorboard is I always kind of like turn smoothing off, right? Maybe click the ignore outliers, especially maybe later once you actually have nicer, cleaner looking logs, you can use those. But in the beginning, you're going to be debugging something. So one of the first things I noticed here is this really weird kind of like pattern. So you can hit toggle all runs and then maybe hit one of these, maybe this one. And this is just a weird, see, it's kind of on all of these, right? There's this kind of situation here where like you get one reading and then you have another reading that also happens at epoch 0. So 2, 1, 1, 3, 3, 4, 4, 5, 5. So there's 2 separate readings happening here. So we're going to have to go into our training code and see what is going on. Why are we getting 2 different losses here? When we train. Okay, now I understand. So here's what's happening is that when we're taking our train loader and we have our epoch, we're logging the loss at every batch within the epoch. But the way that this Tensorboard logging is working, right? The x-axis here is epochs. So what we really want is something like wall time. You see? So wall time shows you the actual curve compared to the epoch. So one thing we could do here is could do like maybe batch I, and then batch data, generate train loader, and we can get the size of the train loader. All right. And get the number of batches per epoch. That's going to be train size divided by that. And then rather than epoch here, when we actually log the loss, let's log basically the batch number. So we're going to say current batch number. And it's going to be the current epoch times the number of batches per epoch plus the batch I. So then we're going to... So that should fix this weird pattern that we were seeing here. But other than that, another thing that we're kind of noticing here is that, if we smooth this a little bit, that this loss is kind of slow, right? It feels like we could actually push this more, right? So one thing that we notice here is that the name of these runs, the last part of it is the learning rate. And you see here 0.0005, 0.0009, 0.0009. So some of these learning rates are pretty small, except for maybe this pink one here. Pink one's a little too big, right? 0.12. But if we actually toggle all of them, wall time, I think we can make these go a little longer. So we can train them for a little bit longer epochs, but then the high learning rate here is not useful at all. Let's go ahead and what are these ones? What are the ones here that are not working? So we have this blue and this green. So this is T33 650 with a batch size of 64, and then this green one, T33 650 URD with a batch size of 64. Maybe it's the 64s. So if we, no, so which one is it? ESM2, is that? Yeah, okay, so you see here, all the ESM2 runs came out no good. So something's going on with the ESM2. So before we forget though, let's again change this to log uniform, maybe instead of -10. Uniform distribution for test ChatGPT. Gotta re-log in. Google account. And you modify this hyper opt parameter so that it samples learning rates uniformly. Move it on this side so you guys can actually. You can modify this hyperparameter so the samples learning rates uniformly between 0.01 and 0.000. We forgot to put the thing. We'll see what happens. I want to use the log uniform. Yeah, look at that. It got it. Log uniform, hp.log uniform. And it even does this trick. So when you're kind of specifying logs, especially for like hyperparameter sweeping like this, sometimes the log uniform function calls will take the like power, but for readability purposes, right, it's actually, some people will do this, right, where they'll give you the number just so whenever someone looks at this code quickly, they can see, oh, okay, this is 0.001, rather than saying whatever this is, -2 or -3, and then they have to kind of like think for a second to come up with that. So go ahead and import NumPy here. Okay. Sort our parameters. Or sort our... okay. What else? We want it to train for more epochs, so let's increase this to maybe 3 times as many epochs, 30. And we have some learning rate scheduling here. This is the learning rate scheduling. So every 10 epochs, it'll reduce the learning rate by 0.1. So that's that. I think and then the last thing we wanted to check is what is going on with, right? So let's go ahead and comment these. And let's run the ESM2. My suspicion is that it's probably running out of memory if I had to guess. Low should be less than high. Okay, so these actually need to be flipped. Actually, one thing we could do yesterday is run our I. So we can see here we're at 23 megs. 2,300 out of 20. Name args is not defined. So actually the code that right here. We need to pass batch size into batch size. Here, pass the batch size to our come here and keep rerunning SMI, see what memory we're using here. I don't know what it's spending its time. Name data is not defined. Okay, so go to our train loop. Yep. Rename this to batch underscore data. So let's add in there. Let's optimize. So while that's going, we can actually come here and pick our best performing runs, which is this red one here, ESM1V, the learning rate of 0.00098. ESM1V with the learning, this one. Copy that. And if you remember, yesterday we made a submission here, right? Go ahead and put that one there. So we're going to combine the predictions from our top performing models. And I also liked this red one at the very end, the ESM1V with 0.90s, the 0.14. That, find that one. And let's pick one last one. Let's do one here. ESM1V at a 0.05. So ESM1V with the 0.5 learning. That one. Look at how our training. Okay, this is what the training looks like. This weird like triangle, that's a TQDM, right? So we're using the TQDM Python package, which just basically prints this little loading bar. And it's useful for training stuff. Actually, let's try a bigger batch here. Generally, the bigger the batch, the better your form. Because a bigger batch size, the smaller your batch, the noisier each individual batch is. So when you're performing gradient descent, right, which is ultimately what you're doing when you're training one of these neural networks, you want to think of like that little marble rolling down the hill. And if you have a very small batch size, right, the direction that the marble will roll down the hill is just based on a couple different training points, right? So the sum total of all of those is actually not going to be necessarily, there's going to be more randomness in that. the bigger your batch size is, the more consistently good the direction that that little marble roll is going to be, right? Maybe not a super great analogy, but generally the bigger batch sizes are better. That's why everyone's always trying to push for the biggest batch size you can. So let's open up a new conda. Go into document, betterer, our dev folder, and then that. And let's run this pi. Running into errors. Submit line 20, so right here. Must have equal length keys values when setting an. I think the problem here is that the average values, let's run this with a PDB, Python debugger. So AVG values is a whole row. For T, X, Y. What is duplicate? Sequence ID is. Sequence ID is 31390. Okay, what are rows? 64 total rows for that have the value for sequence ID 31390. And we want average temperature maximum for all of those. What is X and Y? That only one TM here. I think this code here is maybe a little bit. Let's go ahead and try to get ChatGPT to regenerate that for us. Let's say, can you write Python code for me that combines 3 pandas data frames in one? The headers for the data frame are seek ID, the columns, all of the ID, and then I want to in the combined data frame, I want find all the rows with the same peak ID. Use the average average of the value in my final pandas combined pandas data frame. I want every ID let's see. I think what it was doing here is kind of, it's like weird, like duplicate group by averaging thing. Okay, perfect. Replace. This. And we don't actually need to name best runs. Let's do this, and then let's actually multi here and okay. F average. Now let's run our training. Training is still going, still pumping there. Our other terminal and run this submit file. Okay, final data frame. And go. Sequence ID, EM average. Alrighty, perfect. So that. And we want specifically the we only want the sequence ID and the TM column. And let's call run it. Thank you. .csv. We don't want the row index. Index equals. Right. There we go. Sequence ID and TM. We have the sequence ID and 2,400. Go into sample submission. It'll also be 2,400 in here. Nope. Okay. So let's take the submission. Go ahead and put it into Kaggle. Enzyme Stability Prediction. Let's submit a prediction. Browse our files. Sevenfold. This one is going to be first attempt after embedding. First attempt. Uses mixture. Okay, admit that. See. Ha! Negative score. What? Holy shit. How do we get a negative score for that? Let's look at the... That makes me think that there's something wrong. Look at the train data. Sequence ID, M. What is the TM column look? 75, 48.4, 43, 65, 40.8. And in our sample submission, we have a little bit, maybe too many columns here. Or too many integers. Not too many, sorry, too much precision. So maybe let's ask ChatGPT to round our answer. Here, it. Write a line of code that rounds values M column just decimal. Yes. Copy that. Here, that. Now if we run it, we should get a answer. Okay, this is nicer. So another thing that potentially could be going on here is that the sequence IDs aren't necessarily the same. So why don't we do verify, or can you write code that verifies that sample that two files, sample submission.csv and submission.csv both have same number of sequence ID, same values in their respective columns. I want you to numpy or pandas copy paste that in there. Run it. Seq ID columns are equal. Okay. So we just wanted to make sure that the sequence ID is equal. Absolutely. Back here. Fresh. So this is still going. We're getting a lot better losses. Remember in our old board, the best loss was hovering around 0.2. So now that we're training for longer, we're getting better losses. Okay, so we're going to go ahead and I don't want to commit an event file, so go ahead and add this file type into our, actually, why don't we just add the whole logs directly? Go into our git ignore. Save that, then we go back into it. Yeah, okay. All we're adding is just the optimization here. Have the changes to our submission. Have the changes to our training code. Update for better. Sync that. Right, perfect. So here, back to epoch 0. Control C after that. Let's run our tensor. You know what? We can probably run the tensor dash log logs. Go back to our refresh. Refresh that. Should have one more. Refresh is help out the times full. Modified. Let's get all this. Fix. All right. So this is showing you just how many batches we have, right? Oh, it like resumed training. Try this one. To let's see what we get. This actually, why don't we just put that one directly in? Or no, we need it. Add ombre here. Out. I'll go here. Run all. Generate RGB. Back to Kaggle. Predictions. Look. Enzymes are a little. This one is based only on this one. It's not an average. It's just that one. See what we get. 0.037. All right. At least it's not negative, but it's still a pretty bad score. Where are we at on the lead? Perfect. So at least we beat our baseline. You know, our baseline was 0.005, and it was down here somewhere around the 1900s or 1900. And now we're at 1,700. Still not very good, but at least we're making some progress here. I think if we run this training, more epochs, longer time, I think we might be able to get something a little bit more impressive. So that's good news, guys. Back into our GitHub here. Let's delete all this crap. Clean up our directory here. All these predictions and our submission. And let's also delete all these logs. Okay. OKW to. So we're basically done with this. At this point, the only thing we need to do is just run this optimizer, which will take probably a day to run. Right, it's going to train with a bunch of these files, and then generate. But then we're going to go look at our best performing ones, combine them, and see what happens. It's interesting. Monday when we return, probably go and I'll maybe do a stream where I show you the best performing ones. It's not, and we just end up getting shittier scores. Maybe that's the end of it, and call it there. But pretty good. We're getting on. I wish we could get into the top 10. That would. People are like, they're submitting a lot. Chris Dot, data scientist. This working on all day. He is literally the best. He's the best Kaggler dot ever. Look at this. Rank 1 in discussions, rank 1 in notebooks, rank been 1 in data sets, and he's been 7 in competition. Math reach. I've researched, published, presented. Class note. Renovates. Renovating houses. That's a good life, Bunch of like Kaggle competitions, teach, and also flip houses for extra money. Test check. What? Test. Did dates. Start a. How much I think I could make by house? order to have good chance of making a profit, you'll need to carefully evaluate the potential costs and revenues of flipping a. Why we're not going to be flipping houses. Waste of time. Maybe not a waste of time. It's a lucrative way to do, but some general life advice is that ultimately you kind of want to do what you want to do, right? It's like, don't chase what gives you the most money, chase what you see yourself doing every day, right? And if you're going to try to make money flipping houses, you're going to spend a lot of time thinking about houses and going in houses and talking to contractors about houses and going to Home Depot and buying plumbing stuff. That's going to be your life. So you have to think about, is that what I want my life to be, or do I want my life to be sitting here interfacing with ChatGPT to try to solve a Kaggle problem? Set up. All right, dudes, I'm out of ideas here. I don't really know what else to do. Kind of have to wait for this training to work. So I think we're going to leave it there. Maybe I have a stream this weekend, or maybe I touch base again on Monday. Go from there. Thanks for watching this week.